Here we are. We're doing Unit 6. This is Section 2. So before you do this, you should have done all of the Units 1 through 5 and completed the Section 1 test before you start this Unit 6. This will comprise Section 2, and after we're done the chapters in Section 2, we will have a test at the end of that also. What we're looking at is Unit 6, 7, 8, and 9 comprise Section 2. And after Unit 9, you'll take a Section 2 test. So this is going to be on general provisions. Prior to the 2008 edition of the NEC, only 120 volt single phase 15 and 20 amp branch circuits supplying outlets installed in dwelling units. Bedrooms were required to be an arc fault circuit interrupter protected. Now all 120 volt single phase 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling unit. Kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms, or shall be protected by any of the means described in Section 210.12, Section A, subsection 1 through 6. So if you're interested in figuring out where Section 210.12, Section A, subsection 1 through 6 is located in the book, you're looking at page 56. So it's 70-56 is where it's located. So if you want to read over that, it goes over all of the changes that they made in 2008 and since then, because they've gotten a little more stricter on some of this. Goes into different types of circuit protection devices you need to put in there. For instance, a listed combination type arc fault circuit interrupter installed to provide protection of the entire circuit. A listed branch feeder type AFCI installed at the origin of the branch circuit in combination with the listed outlet branch circuit type arc fault circuit interrupter installed at the first outlet box on a branch circuit. And then this first outlet box in the branch circuit shall be marked to indicate that it is the first outlet of the circuit. Okay, so they're getting a little bit more detailed on the way they identify circuits and where they're putting the arc fault circuit protector. Yeah, I just wanted to go over that part before we start getting into Unit 6 here. What we're going to do is, after studying this unit, you should be able to calculate the minimum number of 15 and 20 amp branch circuits in a one family dwelling. You should know the requirements for a single receptacles or individual branch circuits. You understand the branch circuit ratings allowed for general purpose receptacles. Now, you need to know how to lay out general purpose receptacles in a dwelling, know the receptacle ratings allowed on various size branch circuits, understand the requirements for receptacle boxes, and have a good understanding of split wire receptacles. Again, we need to know the requirements for wet bar receptacles, be familiar with the provisions concerning the minimum length of free conductors inside the boxes, know the receptacle replacement requirements, and understand the general requirements for lighting and switches. You need to be familiar with the use of a white conductor as an ungrounded conductor, understand general requirements for devices and luminaire boxes, know the provisions for outdoor receptacles, be familiar with the provisions concerning luminaire outdoor entrances and exits, and understand the requirements for attaching receptacles or lighting to vegetation such as trees. And you understand electrical blueprints may be optional on a one-family dwelling. Sometimes it's the responsibility of an electrician to design and install the electrical system. On larger installations, that would be done by an electrical firm. Now, the floor plan and the blueprint. First of all, I'm going to talk about what this chapter covers, everything in a one-family dwelling, from a single receptacle to an individual branch circuit, to luminaire of entrances and exits. Some state and local jurisdictions may not allow the use of non-metallic sheath cable in any dwelling. You need to obtain a copy of any additional rules and regulations for your area. Okay, and here we have a picture of a blueprint, a schematic of how they're laid out, where their receptacles are going to reside in the drawings itself. Now, branch circuits, you have AFCI protection, tamper-resistant receptacles and dwelling units. You have general purpose branch circuits. They're required branch circuits. You're going to calculate 15 amp branch circuits or 20 amp branch circuits. Now, an arc fault interrupter, they call that an AFCI, is a device intended to provide protection from the effects of arc faults or shorts by recognizing characteristics unique to arcing and the function to de-energize the circuit. All 120 volt single phase 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling units, kitchen, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas shall be protected by any means described in that section that I talked about, 210.12, section A, subsection 1 through 6. Okay, and there is one thing: a listed outlet branch circuit type arc fault circuit interrupter installed the first outlet on the branch circuit in the combination with a listed branch circuit overcurrent protection device where all of the following conditions are met. Now, the branch circuit wiring shall be continuous from the branch circuit overcurrent device to the outlet branch circuit arc fault circuit interrupter. Okay. Minimum length of the branch circuit wiring from the branch circuit overcurrent device to the first outlet shall not exceed 50 feet. First outlet box in the branch circuit shall be marked to indicate that is the first. The combination of branch circuit overcurrent device and outlet branch circuit AFCI shall be identified as meeting the requirements for a system combination type AFCI and shall be listed as such. Now, in any of the areas specified in 210.12 section A where branch circuit wiring is modified, replaced, or extended, the branch circuit shall be protected by one of the following: a listed combination type AFCI located at the origin of the branch circuit, or 2, a listed outlet branch circuit type AFC located at the first receptacle outlet of the existing branch circuit, which is, I talked about that in 210-12 section B. Now here we have, these are the tamper-resistant receptacles. These are recommended in all areas specified in section 210.52. All non-locking type 125 volt, 15 and 20 amp receptacles shall be listed tamper-resistant receptacles. Okay, and you can see that they're marked right here that they're tamper-resistant. Wait a second, I'm going to check something. AFCI protection shall not be required where the extension of the existing conductors is not more than 6 feet and does not include any additional outlets or devices. Okay, I just wanted to kind of mention that. Here we have the tamper-resistant receptacles are identified by the letters TR. You can see that over here. It's kind of in this area right here, and understand that they're tamper-resistant. It is not required to install tamper-resistant receptacles in the following areas: receptacles located more than 5.5 feet above the floor, receptacles that are part of a luminaire or appliance, a single receptacle or a duplex receptacle for 2 appliances located within dedicated space for each appliance that is normal use. and non-grounding receptacles used for replacements as permitted in section 406.4, section D, subsection 2A. Now, branch circuit requirements. There's a minimum of 220 amp small appliance branch circuits are required. At least 120 amp laundry branch circuit is required, and a minimum of 120 volt 20 amp bathroom branch circuit is required. Okay, those are required branch circuits in a dwelling. Now, general purpose branch circuits may be feed lights, receptacles, or both. Okay, general purpose branch circuit overcurrent protection shall not exceed 15 amperes for a 15 gauge copper, or 20 amperes for 12 gauge copper wire, and 30 amperes for 10 gauge copper wire. Now, branch circuit conductors shall have an AFCI not less than the minimum load to be served. So it depends on the load. Now, to calculate a 15-inch, these are your branch circuits. Calculate to find a minimum number of 15 amp branch circuits. That's our goal here. You want to calculate the general lighting and receptacle load by using table 220-12 in the black book here, this NEMA 70 manual. First multiply, you know the square footage is a 1400 square foot. That's your drawing right here. And your supply voltages, you got to have 240 and 120. That's what you're going to do. So you first multiply the 1400 square feet by 3 volt amperes, which gives you 4200. Calculated the one family dwelling unit, the 15 amp branch circuit. How we do that is first multiply the square footage, which in this case is 1400 square feet, by 3 volt amperes. And that comes as 4200 volt amperes. Next, we divide the total volt amperes by 120 volts to find out the total amperes. So we have 12 divided into 120 divided into 4200 gives us 35 amperes. Finally, divide the 35 amperes by 15 for a 15 amp circuit to find the minimum number of circuits. And that gives us 2.33. So we round up to the next whole number if the result of the calculation is not a whole number. So in this case, we round up to 3 because it gives us 2.33. That's how we find out the minimum number of circuits for a 1400 square foot structure at 15 amps. Now do the same thing for a 20 amp branch circuits. Calculate to find the minimum number of 20 amp branch circuits. And then you calculate the general lighting and receptacle load by using the table 220.12 in your book. Okay. First, you multiply the 1400 square feet, which is the square foot of the building, the structure, and by 3 volt amperes. That gives us 4200 again. Next, divide the total volt amperes by 120 volts to find the total volt amperes, which is 35 from the previously. And then finally, divide the 35 amperes by 20 for a 20 amp circuit instead of a 15 like we did before. Okay, and then we round up to the next whole circuit, so that gives us 2 circuits. 20 divided into 35 goes 1.75. If the 20 amp circuits are installed for general lighting and receptacles, then at least 2 circuits are required. Okay. Branch circuits continue. Individual branch circuits for a water heater, and we're going to talk about ampere rating of receptacles and then a single receptacle on an individual branch circuit. Now, and we're going to figure out the calculations to find the maximum overcurrent protective device for the water heater. The overcurrent protection shall not exceed the rating marked on the appliance. If the rating is not marked and the appliance is rated over 13.3 amps, the overcurrent protection shall not exceed 150% of the rated current. This is stipulated in 422.11 in our manual. So what we take is 18.75 times 150% gives us 28.13. Okay. The 18.75 is now, the calculated rating does not correspond to the standard size fuse or breaker as found in the 240.6 subsection A. The higher standard rating shall be permitted. The next standard size fuse or breaker higher than the calculated rating of 28 amps is 30 amps. Okay. The minimum conductor size is 10 gauge wire, and that's out of your table 310-15.15b subsection 12. And because the overcurrent protection shall not exceed 20 amperes for a 12 gauge copper, 12 gauge conductors are not permitted per 240.4. So you got to use 10 gauge wire. A branch circuit supplying a fixed storage type water heater, which is 120 gallon capacity or less, shall be considered a continuous load. Therefore, it must have a rating not more than 125% of the water heater nameplate. And that's also according to 422.13 and 422.10 subsection A. Now we want to calculate to find the minimum current ampacity. Okay. On the water heater, it has a nameplate. It's a capacity. It says 50 U.S. gallons. Voltage is 240. AC one phase. Wattage is 4,500. So you divide the wattage by the voltage, gives you current. Okay. Or amperage. Okay. Next, you multiply the amperage by 125% as required by 422.13. So we take that and it gives us 23.44. The minimum capacity required for this water heater is 23.44 amperes. Okay. So that tells you what the minimum is. Now you can go up to the 24, you can go up to a 30 amp circuit. Okay. Because it'll make a 25 amp breaker. Now we're going to be talking about receptacles, and circuits must have a rating of 20 amps for laundry areas, bathrooms, kitchens, except for refrigeration equipment supplied from an individual branch circuit, 15 amps or greater. Dining rooms, pantries, breakfast rooms, and similar areas. Throughout the remainder of a one-family dwelling, 15 amp receptacle branch circuits are allowed. Lighting and receptacles can share the same branch circuit except for small appliance receptacles, your bathroom receptacles, unless the circuit supplies a single bathroom, and laundry receptacles. Unit 7 for additional, see Unit 7 for additional information concerning receptacles and lightings in these specific areas. Okay. Now in the drawing, you have which is A, is a receptacle A. Okay. This is on page 112 of your manual if you want to follow along. Receptacles installed on a 15 amp circuit must have an ampere rating not more than 15 amps. Okay. Now we go to B. A 20 amp duplex receptacle should not be installed on a 15 amp circuit. Okay. Now receptacles installed on a 20 amp circuits can have an ampere rating of either 15 or 20. Okay. Now there's a note here. Both circuits for receptacles shall not be smaller than 14 gauge wire. Generally, 15 amp circuits require 14 gauge, and 20 amp circuits require 12 gauge copper conductors. Now, large conductors may be needed to compensate for voltage drops, but most of the time you can get by with 20 amp at 12 gauge and 15 amp at 14 gauge. Now, a single branch or single receptacle on an individual circuit. A single receptacle installed on a branch circuit with no other device or outlet shall have an amp rating not less than the rating of the circuit. So in other words, we want to keep it at, most of the time you're going to run a 15 amp circuit. Installing 2 or more 20 amp receptacles or outlets on a 15 amp circuit is not permitted, but this requirement does not apply to a single receptacle. So we're looking at, that was at D, and then E, we just talked about. A 20 amp receptacle or outlets or on a 15 amp circuit is not permitted, but these requirements do not apply to a single receptacle. See, there's only one receptacle there on E. So you're good. F is 15 amp single receptacle should not be installed on a 20 amp individual branch circuit. Cannot do that. Now, D, we talked about that already. G, a duplex receptacle is not a single receptacle, as defined in Article 100. A single receptacle is a single contact device with no other contact device in the same yoke. Receptacles on 20 amp circuits can have a rating of either 15 or 20 amps. Okay, here we are. We're going to finish this up now. We're going to be talking about receptacles, the general receptacle placement, the wall spacing, maximum distance to a receptacle, your space measurements around corners, your fixed panels, fixed room dividers, examples, railings, freestanding bar type counters, where these outlets are going to be replaced in that regard. Here we have a drawing. The wall space determines the number of receptacles in a given dwelling. The receptacle outlet should be installed in kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, bedrooms, recreation rooms, or similar rooms or areas in accordance with the provisions specified in 210.52 subsection A. Now, that just goes into where they're placed, how far off the ground they're supposed to be placed. Let me check something. Hold on. Yeah, section 210 basically goes into the placement of receptacles around in a dwelling, like what we're talking about. Now, the receptacles required by 210.52A, what 210.52 specifies is basically your dwelling unit receptacle outlets, appliance outlets installed in the dwelling unit for specific appliance such as laundry equipment shall be installed within 6 feet of an intended location of the appliance. And then it goes into other factors about where to place your receptacles. The receptacles required by 210.52A through H shall be, in addition to any receptacle that is, one part of a luminaire or appliance controlled by a wall, number 2, controlled by a wall switch in accordance with 210.70-A. Exception to number 1, located within cabinets or cupboards or located within 5.5 feet above the floor. Now, wall spaces, you want to keep the 2 feet in width. A receptacle is required for any wall 2 feet or more in width, including space measured around corners, unbroken along floor line, by doorways and similar opening, fireplaces, and fixed cabinets. This is also specified in 210.52A. And I'm going to get into maximum distance to a receptacle. An easy way to understand the placement of a dwelling receptacle is to imagine having a floor lamp with a 6-foot cord. Anywhere this lamp is placed around the wall, there should be a receptacle within reach without using an extension cord. So what that means, if you want to move around that lamp, that cord is going to be your designator where you can place that lamp, and those outlets are going to be spaced in accordance to where you can move that lamp anywhere around the room without using an extension cord. And even with placed beside a door opening, an outlet should be within reach. If the lamp is placed next to a wall that is at least 24 inches wide, an outlet should be available within that wall space. Now, the maximum distance to any receptacle along the floor line of any wall shall be measured horizontally, shall be 6 feet. Okay. Now, space measured around the corners. This is the maximum distance between receptacles along the floor line of any wall space measured horizontally shall be 12 feet. Now, in your drawing there, you can see you got 3 foot from one receptacle, 4 feet, 5, that's 9, and 3 is 12 feet to the next receptacle. Okay, they're kind of moved around the corners there. Okay. Now we're going to talk about fixed panels. Glass doors, fixed panels, and exterior walls are counted as wall space. So sliding panels and exterior walls are not as counted as wall space. You know, it's in B right there. And the maximum distance to any receptacle along the floor line measured horizontally shall be 6 feet. Okay, so essentially you can see how that is there. Now we're going to talk about fixed room dividers. This space afforded by a fixed room divider, such as railings or freestanding bar type counter, shall be counted as wall space. So here we have 6 foot railing. We have a floor mounted receptacle mounted on the floor. Receptacle outlets in or on floors are permitted. Receptacles located more than 18 inches from the wall or room divider shall not be counted as required receptacles. In this case, this one is not all types of receptacle boxes are suitable for floor installation, and different types of boxes may be required for different types of floor construction. That is wood or concrete. Receptacle floor boxes must be listed specifically for the type of floor in which they are being installed. Now, we're going to get into these receptacles a little more. We're going to talk about miscellaneous receptacle requirements, balcony, handrail, electric baseboard heaters, receptacles mounted in baseboard heaters, receptacle boxes, and grounding type receptacles. Now, miscellaneous receptacle requirements, we're going to be talking about luminaires or appliances with built-in receptacles are permitted, but these receptacles do not count as required receptacles. So that's telling you that you don't have to worry about 6 feet maximum between, minimum between receptacles here. This one is just, it could be between the two 6 foot, the two receptacles that are over there. Although receptacles located more than 5.5 feet above the floor are permitted, they are not counted as required receptacles. Although receptacle outlets within the cabinets or cupboards are permitted, they are not counted as required outlets. These are just additional outlets that you can add above the counter, above the 5.5 foot requirement. Now, balcony and handrails. A receptacle floor box must be listed specifically for the type of floor in which it is installed, like we mentioned earlier. A floor receptacle may be required if a balcony handrail is longer than 6 feet and the area is listed in 210.52a. Receptacles and baseboard heaters. A baseboard heater more than 12 feet in length does not illuminate. There requirements of 210.52a subsection 1. A receptacle is still required for the wall space containing a baseboard heater. So you're supposed to put in one. Listed or label equipment must be installed and used per instructions included in the listed labeling under 110-3 subsection B. Listed baseboard heaters include instructions that may not be permitted their installation below the receptacle outlets. Now, receptacles and boxes. Also, there was one other thing I wanted to talk about. Receptacles mounted in baseboards heaters, and permanently installed electrical baseboard heaters equipped with factory installed outlets or outlets providing as a separate assembly by the manufacturer shall be permitted, as long as they're up to code. And the receptacle outlets shall not be connected to the heater circuit. These got to be on a different circuit. Receptacle boxes shall comply with Article 314. An expanded description of boxes, including box fill calculations, can be found in Unit 3. We went that over already of this guidebook. Metal raceways, cable trays, cable armor, cable sheets, enclosures, frames, fittings, and other metal non-carrying current parts that serve as equipment grounding conductors with or without the use of supplementary equipment grounding conductors shall be bonded where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed upon them. So in other words, they need to be constructed of material that can handle some sort of current capacity. A connection shall be made between the equipment grounding conductors and a metal box by means of a grounding screw used for no other purpose. And in the drawing there, you can see where your ground is connected to your receptacle, connected to the box, and it's also brought in from the other areas, a part of the circuit. The arrangement of grounding connectors shall be such that the disconnection or removal of a receptacle, luminaire, or other device fed from the box will not interfere with or interrupt the grounding continuity. In this case, when we take the receptacle out, it's still not going to be an issue. Now, the grounding type receptacles, whereas a 14 gauge wire copper conductors are required for the 15 amp circuits, 20 amp circuits require 12 gauge. Now, a non-grounding type receptacle, which is what you see in figure A here, right here, may only be used to replace existing non-grounding receptacles. Now, grounded type receptacles shall be used on 15 and 20 amp branch circuits except as provided in 406.4 subsection D. Now, for 15, 20, and 30 amp circuits, the equipment grounding conductor shall be the same size as the current carrying conductors. So if you have a 15 amp circuit, it's a 14 gauge, 20 amp is 12 gauge, and a 30 amp is 10 gauge. So that would be what all your conductors need to be the same current capacity. Where receptacles have equipment grounding conductor contacts, these contacts shall be grounded by connection to the equipment grounding conductor of the circuit that supplies the receptacle. Again, that's the third conductor that's in there, Romex. Now, receptacles, you have split wire receptacles, wet bar receptacles, room air conditioner receptacle, and the length of free conductor is what we're going to talk about next. Now here, split wire receptacles. A switch has been installed to control one of the multi-wire branches. That's what we show in A over here, right here. And you see how the switch is wired up. Now B is each multi-wire branch must be provided with a means that simultaneously disconnects all ungrounded hot conductors at the point where the branch circuit originates. And this is accomplished through the use of either one double pole breaker or single pole breakers with identified handle ties. Okay. Now, on C, we're going to be talking about a split wire receptacle receives power from a single source. One breaker or one fuse is not a multi-wire receptacle. Okay. And D is a switch control split wire duplex receptacles are sometimes installed in lieu of a lighting outlet. Now the tab has been removed so one receptacle can be controlled from the switch and the other receptacle can remain live with whether the switch is on or off. And that's what's shown in these right here. Okay, right this area here. That's what they're removing the tab. And one half of the duplex receptacle is controlled by a wall switch while the other half is a typical receptacle. Now warning, in multi-branch On multi-wire branch circuits, the continuity of the grounded conductor shall not be dependent on the device. If breaking the grounded conductor at the receptacle breaks the circuit down the line, then the grounded conductors must not be connected to the receptacle. Simply splice the grounded conductors and install a jumper wire to the receptacle. Okay. Now, if you want additional information concerning multi-wire branch circuits, you can check Unit 2. Now, wet bar receptacles. If located outside the kitchen, pantry, breakfast room, dining room, or similar area, wet bar countertop receptacle placement is not specified. This is covered in 210.52 Section C. Regardless of whether receptacle serves countertop space or not, grounded fault current interrupter (GFCI) protection is required of the receptacles within 6 feet of the outside edge of the sink. Okay. But really, in this edition of 2014, they really changed a lot about these GFCI installation. They're really wanting them anywhere near any utensil, appliances, and also being specified as first one in a circuit. CFI protection is required where receptacles are installed within 6 feet of the outside edge of the sink. For cord and plug connection appliances, an accessible separate connector or an accessible plug and receptacle can serve as a disconnect means. Where the separate connector or plug for the receptacle are not readily accessible, cord and plug connection appliances shall have a disconnect means in accordance with 422.31. Okay. You just make sure that the receptacles are easy to get to. Now, room air conditioner receptacle. If supplied by an individual branch circuit, the rating of the cord and attached plug to connection room air conditioner can be no more than 80% of the circuit's operating range. Where other receptacle lighting units or appliances are also supplied, the rating of a cord and attachment plug connecting air conditioner shall not exceed 50% of the branch circuit amperage. Now, the attachment plug can serve as a disconnect means, and the length of the supply cord shall not exceed 10 feet for 120 volt or 6 feet for a 208 or 240 volt air conditioner. And it's also recommended that you put these on separate circuits. It's just a safe way of doing things if you can. Especially if it's a 20 amp, you got to run the proper wire and everything. Length of the free conductors. At least 6 inches of free conductor measured from the point of the box where it emerges from the raceway or cable sheath shall be left at each outlet at 6 inches. Conductors must extend a minimum of 3 inches outside of the box opening. So you have 3 inches inside, 3 inches outside the box, minimum. Where the opening to the box is less than 8 inches in any dimensions. Okay. Now, receptacle replacements, we're talking about grounding means present or installed in the enclosure, no grounding means present, non-grounding type receptacles, non-grounding type, and receptacles requiring GFCI protection, all receptacles serving kitchen countertop surfaces. Now, grounding means present or installed in the enclosure. A grounding type receptacle shall be installed in any receptacle enclosure having a grounding means. If an equipment grounding conductor is installed and connected to the grounding electrode system in accordance with 250.130 Section C, a grounding type receptacle shall be installed. So if it has one, you need to put one in there. Note, an existing 2-wire receptacle may be attached to a metal receptacle enclosure. Just because the box is metal does not guarantee that it is grounded to a grounded electrode system. So you need to make sure that it's grounded somehow. Normally the newer locations are. Non-grounding means present non-grounding type receptacles, non-grounding type. This means where attachment to an equipment grounding conductor does not exist in the receptacle enclosure, a non-grounded type receptacle can be used or replace an existing non-grounding type receptacle. So if there is no grounding, then you can put in one as long as you're not near sinks and other places where you need GFCI. Receptacles requiring GFCI protection. Because of changes in the GFCI protection requirements, some old receptacles must now be replaced with GFCI protection receptacles. This is specified in 406.4 Section D, subsection 3. Now, arc fault circuit interrupter type and grounding fault circuit interrupter type receptacles shall be installed in readily accessible locations. Now, all receptacles that serve kitchen countertop surface shall have GFCI protection. Where replacement of the receptacle type is impractical, such as where the outlet box size will not permit the installation of the GFCI receptacle, this receptacle shall be permitted to be replaced with a new receptacle of the existing type, where the GFCI protection is provided and the receptacle is marked GFCI protected, and no equipment grounding in accordance with 406.4 Section D, subsection 3, 2A through C. And there's an exception section also, which is 406.4 D, subsection 3. So essentially what it's saying is if you can't use it in that box, then you got to follow the guidelines stipulated in those sections. Now, receptacle replacements. No grounding means is present. GFCI replacement non-grounding type must be labeled no equipment ground. GFCI and grounding type replaces non-grounding type. Now, grounded type replaces non-grounding type. Okay, these are sections that we're going to be talking about with the way we're going to deal with these outlets or receptacles. Here we have no grounding means present, and so we're going to be looking at the receptacle. The GFCI receptacle must be labeled no equipment grounding. Okay. And there's a few others here that we have to talk about. No grounding means present replaces non-grounding. Where the attachment to an equipment grounding conductor does not exist in the receptacle enclosure, the GFCI receptacle can replace the old receptacle. This GFCI receptacle must be labeled no equipment grounding. So in other words, you can put the receptacle in there, but if there's no existing grounding, then you'd have to label it as such. That means that there's no grounding means present, and a GFCI replaces non-grounding type. And no grounding means present. GFCI and grounding type replaces non-grounding. Again, this is the GFCI replaces receptacles must be labeled no equipment grounding, and where attachment to an equipment grounding conductor does not exist to the receptacle enclosure, a GFCI receptacle can replace an existing non-grounding receptacle. A grounding type receptacle may replace a non-grounding type receptacle where the circuit is ground fault protected. These receptacles shall be labeled GFCI protected and no grounding, no equipment ground. Do not connect an equipment grounding conductor between the non-grounding type receptacle and the grounded type receptacle. And we're looking at D here. So it's just a 2-wire circuit. An equipment grounding conductor shall not be connected from the GFCI type receptacle to any outlet supplied from the GFCI receptacle. In other words, we're not going to run a ground because there's no ground there. So arc fault circuit interrupter type and grounding fault circuit interrupter type receptacles shall be installed in a readily accessible location. Okay. Now, receptacles requiring AFCI where outlet supplied by branch circuit that requires an AFCI protection. Replacement receptacles at this outlet shall be a listed outlet branch circuit type AFCI receptacle or a receptacle protected by a listed outlet branch circuit type AFCI type circuit receptacle or a receptacle protected by a listed combination type AFCI type circuit breaker. And the AFCI protection requirements are listed in 210.12 in the section in the NEC manual. Now, receptacles requiring AFCI protection where a receptacle outlet is supplied by a branch circuit that requires arc fault circuit interrupter protection as specified elsewhere in the NEC manual, a replacement receptacle at this outlet shall be one of the following. It needs to be a listed outlet branch circuit type arc fault circuit interrupter receptacle. Okay, and there's a picture of it right there. And a receptacle protected by a listed outlet branch circuit type of arc fault circuit interrupter type receptacle, or a receptacle protected by a listed combination type arc fault circuit interrupter, and then there's also a circuit breaker. This requirement became effective in January of 2014. Requirements for arc fault interrupter protection are listed in 210.12. Listed tampered resistant receptacles shall be provided where replacements are made at receptacle outlets that are required to be tamper resistant elsewhere in the National Electric Code in section 406.4D5. Now, other considerations when replacing receptacles. You want listed tamper-resistant receptacles shall be provided as required. They need to be identified by a TR or tamper-resistant, and a weather-resistant receptacle shall be provided as required, and they need to be identified by the letters WR or weather-resistant. Now, listed tamper-resistant receptacles shall be provided where replacements are made at receptacle outlets that are required to be tamper-resistant elsewhere in the NEC, and are covered in 406.4. In areas specified in 210.52, all non-locking type 125 volt, 15 or 20 amp receptacles shall be listed tamper-resistant receptacles, and it's stipulated in 406.12a. Now, tamper-resistant receptacles are identified by the letters TR or the words tamper resistance. After the receptacle has been installed, the identification is only required to be visible when the cover plate is removed. Now, weather-resistant receptacles shall be provided where replacements are made at receptacle outlets that are required to be protected elsewhere in the NEC manual, section 406.4D. Subsection 6, all 15 and 20 amp, 125 and 250 volt non-locking type receptacles installed in damp and wet locations shall be listed as weather resistant. Now, weather resistant receptacles are identified by the letters WR or the words weather resistant. After a receptacle has been installed, the identification must be visible with the cover plate secure in place. So they'll have the letters written on the receptacle itself with the cover plate installed. Two differences there. Tamper resistant, you only know that the receptacle is tamper resistant by looking for the letters TR or tamper resistant for the words, but whether one is you're able to tell with the cover plate installed. Lighting and switching, you have outdoor entrances and exits. At least one wall switch control the lighting outlet shall be installed in every habitable room of the dwelling. At least one wall switch control lighting outlet is required to provide exterior side illumination of outdoor entrances or exits having grade level access. Remote control or automatic lighting controls are permitted for outdoor entrances. This is stipulated in 210.70 section A subsection 2. And that's your exception list. Now, we're going to talk about general lighting next. General lighting, all switches shall be located so that they may be operated from a readily accessible place, not more than 6 feet from the floor to the center of the switch operating handle. No other height requirements are stipulated for wall switches. Dwelling hallways require a minimum of one wall switch control. Okay. At least one wall switch controlled lighting outlet shall be installed in every habitable room and bathroom of a dwelling. So what it's telling us is there needs to be a wall switch on every entrance to the wall into the room. Now, lighting and switching. Switches controlling light loads, ceiling suspended paddle fans, and cables installed to feed switches. Now we're going to talk about, first thing I'm going to talk about before talk about the fan is switches controlling lighting loads. Where switches control lighting loads supplied by a grounded general purpose branch circuit, the grounded circuit conductor for the control lighting circuit shall be provided at the switch location. The provision of a fixed future grounded conductor is to complete a circuit path for the electrical lighting devices. The grounded circuit conductor shall be permitted to be omitted from the switch enclosure for the following reasons. And you can look those up on 123 in your book. Okay. Basically, where the conductor is entered the box enclosure, closing the switch, where the box enclosing the switch is accessible, where snap switches with integral enclosures comply with section 300.15 section E, and where a switch does not serve as a habitable room or bathroom, and where multiple switch locations control the same lighting load. Now, ceiling fan, paddle fans, suspended outlet boxes or outlet box systems used as a sole support of a ceiling suspended paddle fan shall be marked by the manufacturer as suitable for this purpose, and shall not support ceiling suspended paddle fans that weigh more than 70 pounds. For outlet boxes or an outlet box system designed to support ceiling fans suspended, the paddle fans that weigh more than 35 pounds, the required marking must include the maximum weight that can be supported. We don't want the fan falling on anybody. In a completed installation, each outlet box shall be provided with a cover unless covered by the means of the ceiling suspended paddle fan canopy. Canopies of ceiling suspended paddle fans and outlet boxes taken together shall provide sufficient space so that conductors and their connecting devices are capable of being installed within NEC guidelines. Ceiling suspended fans must be supported independently of the outlet box or outlet box systems identified for use and installed in accordance with the NEC manual. Now, general lighting, again, all switches, I already talked about this, they're all going to be generally located where you enter the room. Now, outdoor receptacles and lightings, required outdoor receptacles, balconies, decks, and porches, receptacles in damp and wet locations, receptacles more than 6 foot 6 inches above grade, and equipment outlets. That's what we're going to talk about here. Now, the required outdoor receptacles in one-family dwellings require at least one receptacle outlet installed at the front and back of the dwelling. Each receptacle must be readily accessible from grade and located not more than 6 feet 6 inches above grade level. Each grade level unit of a two-family dwelling requires at least one receptacle outlet installed at the front and the back of the dwelling. Each receptacle must be readily accessible, not more than 6.6 feet above grade. Now, balconies, decks, and porches. Balconies, decks, and porches that are attached to the dwelling unit and are accessible from inside the dwelling unit shall have at least one receptacle outlet accessible from the balcony, deck, or porch. And this receptacle outlet shall not be located more than 6.5 feet above the balcony deck. Receptacles of 10 and 15 and 20 amperes installed in wet locations shall have an enclosure that is weatherproof, whether or not the attachment plug cap is inserted. An outlet box hood for this purpose shall be listed and shall be identified as extra duty. All 15 and 20 amp, 125 and 250 volt non-locking type receptacles shall be listed weather resistance. Now, all decks, balconies, and porches that are accessible from inside the dwelling unit must have required receptacle outlet, and that's regardless of size. There is no exception for small balconies, decks, or porches. For example, a balcony with an area of 10 foot squared is on the second floor of a new dwelling. The balcony is outside but is accessible from inside the dwelling. Although the balcony is small, a receptacle outlet must be installed. And receptacles in damp and wet locations. An outdoor receptacle located protected from the weather or in other damp locations requires an enclosure for the receptacle that is weatherproof when the receptacle is covered. The attachment plug not inserted and receptacle covers closed. Okay, that's what that means. Receptacle locations protected from the weather include areas such as under-roofed, open porch, canopies, marquees, etc., that are not subject to a beating rain or water runoff. The enclosure for a receptacle installed in a flush-mounted outlet box in a finished surface requires the use of a weatherproof faceplate assembly that provides a weather-tight seal between the plate and the finished surface. That would be this one right here. Right here. Receptacles of 15 and 20 amperes installed in a wet location shall have an enclosure that is weatherproof whether or not the attachment plug is inserted. An outlet box hood installed for this purpose shall be listed and shall be identified extra duty. And again, these are the hoods that they're talking about here. All 15 and 20 amp, 125 to 50 volt non-locking receptacles installed in damp wet locations shall be listed weather resistant. And you see these terms on these receptacles. All non-locking type 125, 15, and 20 amp receptacles in all areas specified shall be listed tamper resistant. So they're tamper resistant and weather resistant. And here's the markings on them. Receptacles more than 6 feet 6 inches above grade for a one-family dwelling, and each unit of a two-family dwelling that is at grade level. At least one receptacle outlet readily accessible from grade and not more than 6.5 feet above grade level shall be installed at the front and back of the dwelling. We talked about that before. Balconies, decks, and porches that are attached to the dwelling unit and are accessible from inside the dwelling unit shall have at least one receptacle outlet accessible from the balcony, deck, or porch. And so GFCI protection is not required for receptacles that are not readily accessible and are supplied by a branch circuit dedicated to electrical snow melting, de-icing, or pipeline and vessel heating equipment. The installation must comply with section 426.28 or 427.22 as applicable in the NEC manual. I have a little note here. It says out-the-bore receptacles require GFCI protection according to 210.A, section A, subsection 3. So now your equipment outlet, 125 volt single phase 15 or 20 amp rated receptacle outlet shall be installed at an access point or location for servicing of heat and air conditioning refrigeration equipment. The receptacle shall be located on the same level within 25 feet of the heating, air conditioning, and refrigerating equipment. At least one receptacle outlet readily accessible from the grade, not more than 6.5 feet above grade level, shall be installed at the front and back of the dwelling. If installed in accordance with both 210.52 section E and 210.63, only one receptacle outlet is required. Outdoor receptacles and lighting, support for receptacles, enclosures, luminary of entrance and exits installed in at least one lighting outlet and in wiring and trees. That's what we're going to talk about next. Support for receptacle enclosures. Basically, the easiest thing to think of is you look at the B, readily and securely fasten and place all boxes and raceways. Okay, A is not a good way to do it here because you can't have one conductor support in the box. You can have two conductors or two conduits. And enclosure containing devices can be supported by two conduits under the conditions found in the NEC manual. The size of the box should not exceed 100 square cubic inches. The box has either threaded entries or identified hubs, and the box shall be supported by two or more conduits threaded wrench tight into the enclosure or hubs. So this can't be PVC, it has to be something screwed in. You know. And illumination of entrances and exits. Install at least one wall switch controlled lighting outlet to provide illumination on the exterior of the outside entrances and exits. You put them in doorways and entrance to the house or structure. Install at least one receptacle outlet at the front and back of the dwelling. And all outdoor receptacles need to be GFCI protected. Now, wiring in trees, outdoor luminaries and associated equipment can be supported by the trees. You can see how they're supported. You're running your conduit up the wall, up the tree. And in vegetation such as trees shall not be used to support overhead conductor spans. So right here you can see where you got them going between the trees. That's a no-no. You can go up the tree with it, but you can't run power crossways like that to feed the other circuit. Now, I'm going to do a summary. All 120 volt single phase 15 and 20 amp branch circuits supplying outlets or devices installed in dwellings, units, kitchen, family rooms, dining rooms, living rooms, parlors, libraries, dens, bathrooms, sunrooms, recreations, closet, hallways, basically every room in the house shall be protected by any of the arc fault circuit interrupters described in section 210.12. Usually we're talking about circuit breakers in the box. Now, all non-locking type 125, 15, and 20 amp receptacles in all areas specified in the NEC shall be listed tamper-resistant receptacles. Balconies, decks, porches that are attached to the dwelling unit are accessible from inside the dwelling unit shall have at least one outlet accessible from the balcony, deck, or porch. General purpose branch circuits may feed lights, receptacles, or any combination of those items. An individual branch circuit feeds only one piece of equipment. In other words, if you have an air conditioner or a water heater, you got a branch circuit going to that circuit that cannot feed anything else. An individual branch circuit feeds only one piece of equipment. The maximum distance to any receptacle measured horizontally along the floor line is 6 feet. Okay. Receptacle is required for any wall space 2 feet or wider. Now, where connected to a branch circuit supplying 2 or more receptacles or outlets, receptacles rated 20 amps are not permitted on a 15 amp circuit. Both 15 and 20 amp receptacles are permitted on 20 amp circuits. Okay, you can use a 15 on a 20, but you can't put a 20 on a 15 amp. GFCI protected receptacles may replace non-grounding type receptacles where the receptacle enclosure is without a grounding means. And GFCI protected receptacles and non-grounding systems must be marked in accordance with 406.4 Section D, subsection 2 provisions. A means to simultaneously disconnect all ungrounded conductors must be provided on a multi-wire branch circuit. Switch-controlled lighting outlet shall be installed in every habitable room of a dwelling. And that includes your bathroom, hallways, and stairwells. Where switches control lighting loads supplied by a grounded general-purpose branch circuit for other than items described in the 404.2 Section C, subsection 1 through 7, the grounded circuit conductor for the controlled lighting circuit shall be provided at the switch location. Boxes are permitted to support luminaries weighing 50 pounds. Now, listed boxes are permitted to support ceiling fan weight no more than 35 pounds. And one-family dwellings require at least one exterior GFCI protected receptacle outlet at the front and back of the dwelling. Now, outdoor entrances and exits must have at least one wall switch controlling lighting outlet. Although lighting and receptacles can be supported by trees, trees shall not support overhead conductor spans. Okay, so we're done with this now.